This episode is called AI 171, The Hidden Scale of the Investigation. 24 aircraft out of 27 in the Air India Boeing 787 fleet have been in an extended maintenance check or retrofit. 16 before the crash of VT-ANB and 8 after the crash. Only 3 aircraft have not, and the crash aircraft VT-ANB was the oldest of the remaining 3. The investigation into Air India Flight 171 is not confined to one airline, one aircraft, or even one country. The maintenance history of Air India's Boeing 787 fleet extends across several international maintenance organizations. The aircraft itself contains systems designed, manufactured, and supported by an extensive global supply chain. The investigation involves accident authorities, regulators, manufacturers, suppliers, insurers, and government institutions in several countries. Each possible finding would allocate responsibility and potentially billions of dollars in corrective action and liability, differently between Air India, Tata, Boeing, GE Aerospace, Safran, other suppliers, insurers, and government authorities. That is the hidden scale of the investigation. Welcome to Independent Aircraft Investigations. My name is Richard Godfrey. The D-check is normally expected after 12 years of service life for a Boeing 787. Flight Radar 24 records identify 19 extended D-check programs across the Air India Boeing 787 fleet, accounting for 2,158 aircraft days and averaging approximately 114 days for each visit. These include visits to Joramco's MRO facility in Amman in Jordan, formerly Royal Jordanian's maintenance organization, and now controlled by the Dubai Aerospace enterprise, and facilities associated with Singapore Airlines in Singapore, and facilities associated with Etihad Airways in Abu Dhabi. The majority of the C and D level maintenance of the Air India Boeing 787 fleet has been outsourced. This does not establish any fault, but greatly extends the documentary and technical investigation. What were the maintenance work packages? What were the components that were removed and installed? What were the defect histories, the test results, software or configuration changes, and the release to service responsibility, and the oversight by Air India and the relevant regulators? For this analysis, the maintenance period begins when the aircraft arrives at the identified maintenance facility and ends when it departs that facility to return to its home operating base. Any time spent in India before departure to the facility or after its return, but before normal commercial service resumes, is excluded. They do not establish continuous active maintenance. This limitation is particularly relevant in Mumbai, where aircraft may also have remained parked while awaiting hangar capacity or parts or engineering action or operational return. Air India operated 27 Boeing 787 aircraft before the crash of VT-ANB. For this fleet-level analysis, maintenance visits lasting fewer than 30 days are classified as C checks, while visits lasting 30 days or more are classified as D checks. Before the crash, 16 aircraft had already completed D-level maintenance. After the crash, a further 8 aircraft entered a standalone D-check, or Air India's separate retrofit program at the Boeing facility in Victorville. The retrofit changes the interior configuration, upgrades the avionics to the latest standard, and incorporates all the D-level maintenance. By July 2026, 24 of Air India's 27 Boeing 787s had therefore undergone or entered D-level maintenance. Only 3 aircraft had not: the VT-ANB, VT-ANS, and VT-ANY. VT-ANB was the oldest of these 3. It entered service on the 14th of December 2013, and the AAIB preliminary report states that its D-check was planned for December 2025, almost exactly 12 years after entry into service. Its D-check was therefore not overdue. However, it was the oldest aircraft in the fleet that had not undergone D-level maintenance, while numerous younger aircraft had already completed such work. The longest continuous absence from normal operations identified in VT-ANB's Flight Radar 24 history before the crash was only 6 days. The investigation should therefore establish why D-checks were brought forward on so many other aircraft, what defects or recurring conditions were found, and whether any of those findings were relevant to VT-ANB before its planned December 2025 D-check. VT-ANP and VT-ANT have completed the retrofit program. VT-ANC, VT-ANQ, and VT-NAC have entered and remain currently in the program. The retrofit program must therefore be understood as a post-crash fleet intervention, not as evidence of Air India's maintenance planning before the accident. Why did Air India bring forward D-checks on 11 Boeing 787 before they reached 12 years of service? How were those aircraft selected? What defects, deterioration, or recurring conditions were found? And were any of those findings relevant to VT-ANB before its planned D-check? We've discussed defects and corrosion and water ingress, wiring deterioration, connector condition, software changes and modification status across comparable aircraft, and that could be important comparative evidence. This episode does not allege that any organization has deliberately delayed the investigation. We simply identify the true scale of the investigation. We examine why the absence of substantive findings after 12 months is so consequential. Until causation is established, the investigation cannot finally determine who was responsible, what corrective action is required, whether the wider Boeing 787 fleet is affected, or how potentially billions of dollars in cost and liability should be allocated. The continuing uncertainty postpones those decisions. The principal human cost, however, continues to be borne by the families of those who died. Air India Engineering Services Limited, AIESL, and Lufthansa Technik Both provide line, base, engine, and related maintenance services across a mixed Airbus and Boeing fleets, including short-haul and long-haul aircraft. Using each company's published figures for aircraft supported, AIESL employs approximately 5,000 people and supports 438 aircraft, equivalent to 11.4 employees per aircraft. Lufthansa Technik employs approximately 25,000 people and supports around 11,000 aircraft, equivalent to 2.3 employees per aircraft. Lufthansa Technik therefore supports approximately 5 times as many aircraft per employee and generates more than 7 times as much revenue per employee. Lower Indian wage levels explain part of the revenue difference, but not the five-fold difference in aircraft throughput. The comparison identifies organizational productivity as one plausible contributor to the longer periods recorded at Mumbai. In another external comparison, I examined a random sample of 7 Boeing 787-8 aircraft operated by ANA, whose fleet includes aircraft up to approximately 15 years old. The sample D-checks average 49.3 days. That is very close to the Air India D-check durations recorded at Singapore and Amman, which averaged approximately 47 and 49 days respectively. By contrast, aircraft associated with D-check activity at Mumbai remained there an average of approximately 139 days. This does not prove that the work itself took longer in Mumbai. The recorded interval may include parking time, but it confirms that the much shorter overseas durations are consistent with D-check experience at other established Boeing 787 operators. Campbell Wilson promised that Air India would be fully transparent and would support the investigation for as long as necessary. That promise could apply to Air India's own records, cooperation and communications, but Wilson could not compel the AAIB or the Indian government to publish evidence. Wilson has now resigned as the Air India CEO, and Tata has not yet announced a permanent successor. Air India therefore faces the continuing investigation during a period of management transition, operational pressure, and substantial financial losses. For Tata Sons, Air India was already a major financial commitment before the crash. Air India Group recorded a consolidated loss of 10,859 crore rupees in the financial year 2024-2025, approximately $1.1 billion. Disclosures by shareholder Singapore Airline indicate that the loss increased to more than 26,000 crore in the financial year 2025-2026, although currency conversion and accounting presentation produce some variation in the reported figures. Tata therefore faced the combined burden of continuing operational losses, fleet transformation costs, compensation, and insurance consequences, reputational damage, and potentially reduced passenger confidence. Air India is also not an ordinary private airline in political terms. It remains India's flag carrier, was formerly state-owned, and its revival under Tata has been presented as a very important national industrial project. Depending on the evidence, a finding involving deficient maintenance, management oversight, crew actions, operating procedures, or organizational safety culture would therefore affect both Tata's stewardship and the Indian government's regulatory credibility. For Boeing, VT-ANB was the first fatal accident involving a Boeing 787. Even if the basic airframe and engines are ultimately found not to have suffered a conventional mechanical failure, any finding involving the aircraft electrical architecture, the fuel control command paths, any common mode failures, the cockpit controls, warning logic, system integration, certification assumptions, or inadequate failure containment could have consequences extending across the global 787 fleet. Boeing ended 2025 with a commercial aircraft backlog exceeding 6,100 aircraft and total company backlog of $682 billion. The 787 is therefore strategically and financially important. It is not a peripheral legacy program. A design-related finding could lead to service bulletins, airworthiness directives, retrofit costs, compensation claims, and renewed scrutiny of Boeing's certification and safety management processes. None of those consequences follows merely from the occurrence of the crash. They depend on causation. According to Reuters, Stephanie Pope, the president and chief executive officer of Boeing Commercial Airlines, traveled to India and met Natarajan Chandrasekaran, the chairman of Tata Sons and the chairman of Air India. The meeting took place on Monday, the 16th of June. And it took place at Air India's headquarters in Gurugram. And Pope was accompanied by Boeing India President Salil Gupta. The meeting demonstrates that the accident was treated from the outset as an issue requiring direct engagement at the highest corporate level. The GE NX-1B is a GE Aerospace engine, but its control and accessory systems include equipment supplied through a wider international supply chain. Safran-related entities have publicly identified roles in FADEC and engine control equipment associated with the GE NX program. If the investigation ultimately concerns the electronic engine control, the EEC, or the fuel metering, or the engine control power supplies, the control channel communication, the shutdown logic, the relight behavior, or common causes affecting both engines, the implications could extend beyond the physical engine cause to the suppliers responsible for the relevant control hardware and software. Reuters reports that investigators conducted engine testing in April and traveled to France in May as part of an analysis of what its source described as the Engine Management Unit. The AAIB has not publicly identified the French facility, the component examined, or the organizations involved. A modern aircraft accident may involve interfaces between systems designed and supplied by several different companies, even where no individual component has suffered a conventional mechanical failure. The relevance of any supplier depends entirely on the systems ultimately implicated. Supply chain involvement identifies records and interfaces and responsibilities that investigators may need to examine. It does not establish fault. The manufacturers and suppliers potentially touched by the investigation operate within a global commercial aircraft manufacturing industry generating approximately $350 billion annually. Even a narrowly defined technical finding could therefore affect products and contracts and fleets far beyond Air India. The Indian government's aviation safety framework contains several overlapping institutional responsibilities that create, at minimum, an appearance of institutional tension. AAIB India is the lead investigator. DGCA is the regulator. Several DGCA personnel have also participated in the AAIB investigation. The Ministry of Civil Aviation has administrative responsibility for both organizations. India is seeking major investment and manufacturing partnerships with Boeing and Airbus, GE and Safran and other aerospace groups. The outcome may affect relations with the United States and France. The accident has generated litigation and Supreme Court scrutiny within India. The AAIB is formally an office of the Ministry of Civil Aviation, rather than a structurally separate parliamentary or judicial body. That does not prove political interference, but it makes transparency particularly important where the ministry is simultaneously defending the competence of the Indian aviation regulation. The participation of DGCA personnel in the investigation can provide necessary technical expertise. However, if the adequacy of the DGCA oversight becomes part of the investigation, clear separation is required between the regulator's technical contribution and the assessment of its own performance. A prolonged official investigation can be technically justified where specialist examinations are incomplete. That does not establish that the delay is intended to protect those interests. It establishes that while uncertainty continues, the technical, regulatory, and legal consequences remain unsolved for several powerful institutional participants. The central issue is therefore not simply whether one company made a defective component. It is whether the investigation ultimately identifies an airline operational failure, a maintenance failure, an aircraft level design, manufacture, or integration failure, an engine control failure, a component defect, an inadequacy in the certification assumptions, or a combination of organizational and technical failures. Each outcome reallocates responsibility and potentially billions in costs between Tata, Air India, Boeing, GE Aerospace, Safran, and other suppliers, insurers, and government authorities. That is why absence of a substantive interim report after 12 months is politically and financially much more consequential than the AAIB's two-page statement acknowledges. The scale of the official investigation is enormous. India is the state conducting the investigation. Under Annex 13, accredited representatives and advisors from states connected with the aircraft design, manufacture, engine, and the fatalities on board have all participated. The investigation therefore involves numerous organizations with different formal roles: AAIB India, US NTSB, the UK AAIB, the Canadian TSB, Portugal's GPIAAF, together with the technical participation from regulators, Boeing, GE Aerospace, and others. We have shown that the maintenance history of Air India's Boeing 787 fleet extends well beyond Air India's own facilities. The recorded ADS-B data from Flight Radar 24 shows the shutdown and restart positions corresponding to the aircraft's location near those facilities. And satellite imagery shows aircraft parking and hangar access at the same locations. Other aircraft were sent to Boeing's Victorville facility for retrofit work. The tracking evidence identifies the facility visited and establishes the duration of the aircraft's stay. It does not, by itself, reveal the complete maintenance work package, individual component actions, contractual responsibility, or release to service documentation. Jeffrey Thomas and I published 128 programs examining the accident and its wider context. We have analyzed the electrical architecture, reported on water ingress, the RAT timing, maintenance history, enhanced fleet inspections, and previous regulatory findings against Air India. Yet the decisive evidence remains unpublished, and it's a long list. The FDR, CVR, ACARS, and AHM data, the radar, ATC, and CCTV data, the Air India and Boeing records, the maintenance records from Etihad Airways, Singapore Airlines, and Joramco. Then there are the open technical questions, including the cockpit pilot microphones and the cockpit area microphone, engine testing in April and May 2026, and a visit to France by the investigators concerning the engine management analysis. The specific site has not been publicly confirmed, but France is potentially significant because Safran-related entities participate in the GEnx-1B engine control supply chain for the Boeing 787, including FADEC-related equipment. That makes a Safran FADEC-related technical review a plausible interpretation of the Reuters reference, although it remains an inference rather than a confirmed fact. I have published 3 unofficial independent reports: an initial report on the 28th of June 2025 titled Air India Possible Crash Scenario, a preliminary report on the 12th of August 2025 titled Air India A Plausible Hypothesis, an interim report on the 19th of October 2025 titled Air India Accident Root Cause. My current working hypothesis is that a temporary loss of valid command or communication data between the aircraft systems and both electronic engine controls caused the initial loss of thrust. The recorded movement of both fuel control switches from run to cutoff and then back to run does not contradict that hypothesis. It is consistent with the crew initiating the prescribed dual engine relight procedure. The switch movements would therefore have been a response to the loss of thrust rather than its initiating cause. If valid electrical supplies and communication were then restored, Returning the switch to run would allow the engine controls to initiate a relight. The recorded relight response of both engines is consistent with a transient interruption rather than the catastrophic mechanical failure of both engine cores. Tragically, there was insufficient altitude, airspeed, and time for the engines to recover useful thrust before impact. The consequences of delay have also reached the Supreme Court of India. In February 2026, the court required the Indian government to provide within 3 weeks a status report on the investigation and an account of whether the required international procedures were being followed. No response from the Indian government has yet been made publicly available, and I have found no public report confirming that one was filed. Separately, 4 months after the court's direction, the AAIB published only a 2-page anniversary statement containing no substantive technical findings. The continuing absence of findings has also created an environment in which campaigners, consultants, and intermediaries can promote their own technical narratives, legal strategies, and commercial proposals. There is direct evidence that the unresolved causation has already created an environment for organized interest protection strategies. I have received 2 documents written by the Toulouse-based aerospace consultant Jean-Philippe Gay. The first advanced his own technical explanation of the accident while promoting his Gilder configuration management services. The second attempted to associate my independent research with his analysis and explicitly proposed a working group to defend the interests of Air India and Tata, to be based at the Tata Consultancy Services site in Toulouse. I have no evidence that Air India or Tata Sons requested, authorized, or supported Mr. Gay's actions. However, the proposal is direct evidence that an outside intermediary perceived unresolved causation as creating a need or an opportunity to organize around the protection of Air India's corporate interests. So, what is our conclusion? The hidden scale of this investigation is now clear. It extends across Air India's maintenance planning, international MRO facilities, aircraft and engine controls suppliers, regulatory institutions, insurers, and government authorities. So who benefits now from the continuing uncertainty? The Indian government avoids for now a definitive judgment on the effectiveness of its regulatory system. Tata Sons and Air India avoid for now a final finding on operational, maintenance, or management responsibility. Boeing, GE Aerospace, and the wider 787 supply chain avoid, for now, a finding that could require fleet-wide corrective action or expose a design or component defect. Insurers can continue making interim assessments without a final allocation of responsibility. I am not suggesting that these organizations are acting together. I am saying that the absence of a substantive technical account postpones the moment when responsibility, corrective action, and final liability must be confronted. The families of the victims receive no corresponding benefit from that uncertainty. They continue to bear its human and financial consequences. The wider aviation community also pays a price because unresolved causation delays the identification and application of any necessary safety lessons. The aviation community cannot fully identify, evaluate, and apply the safety lessons from this accident until the investigation publishes the evidence, the findings, the causes, and the contributing factors. Many thanks for watching. If you support this analysis, then please subscribe to the channel to support further independent aircraft investigations.